All right, so chapter 10, we're basically going to be looking at relationships between two variables. We're really going to be focusing on correlation. Before we do correlation, though, we want to talk about displaying relationships with scatter plots. So in previous chapters, we analyzed numerical data using graphical displays like dot plots, box plots, and histograms. But in this chapter, we're going to analyze the relationship between two numerical variables and focus on how well one numerical variable predicts the outcome of another. So you guys have heard of scatter plots before. We know that a scatter plot is a graph that displays the relationship between two numerical variables. So we cannot graph anything that deals with categorical variables in a scatter plot. Each variable has to be numerical in nature. So again, it's the graph that displays the relationship between two numerical variables. So we have, eventually we'll be trying to use this to make predictions. So we're going to have the explanatory and the response variable. The explanatory variable is, I don't want you to think about it as an input, but of the two, it's the one that's plotted on the x-axis. It's the one that kind of would determine the outcome of the response variable, which is plotted on the y-axis. It's the response variable that we're usually more interested in because we usually want to predict a response for a particular value of the explanatory variable. So the response is really like what we're concerned with. So example 1 says, suppose that we want to determine if heavier cars use more gasoline. 8 cars were selected at random. The weight in hundreds of pounds and gas mileage in miles per gallon were recorded for each car in the table. Which variable should be the explanatory variable? Explain. Well, let's see if we can think about what one we'd be more concerned with. What are we really more concerned with in a car, the weight or the gas mileage? It's the gas mileage that we're more concerned with. And wouldn't it be possible that weight could potentially be used to explain or to estimate the gas mileage that the car has? So we think that the weight might explain this gas mileage that we're looking for. So that means that weight should be the explanatory variable. And that's because weight could potentially be used to estimate the gas mileage a car gets. So again, gas mileage was what we were interested in. So that means that that's the response variable. So by default, weight then is the explanatory variable. Again, weight could potentially be used to estimate the gas mileage that a car gets. So let's organize this data in a scatter plot. When you have a scatter plot, there is no area principle like we talked about with the categorical variables. You do not have to start the scales at 0, but we do need to make sure that all the values fit on the graph. So if I look at the weight, for example, notice that there are no, like the smallest weight that I see is 23, and the biggest one I see is 47. I might not want to go all the way from 0 to 50. I might just want, so it looks a little better, is along the x-axis, I could put the weights, but maybe I'll have like a little jump, and I'll start here with 10, and then maybe I could go by 2s, 2, 4, 6, 8, 20, 2, 4, 6, 8, 30, 2, 4, 6, 8, 40, 2, 4, 6, 8, 50. And maybe I wouldn't have been able to go by such a small unit if I hadn't done that little jump. So that's just a little demonstration. But when you do a jump, you should have an indicator on the axis. In addition to labeling that numerically, I'm also going to say what this represents. The explanatory variable we said was the weight in hundreds of pounds. And now let's do the response variable. So the response variable, notice, goes, like the lowest one is 13 and the highest one is 30. So maybe again I could jump and start at 10 and then maybe go by twos. 2, 4, 6, 8, 20, 2, 4, 6, 8, 30. And again, this was, I'll turn it over around, this was gas mileage, and that they were measuring in miles per gallon. So first you want to set up the axes. You do not have to jump by the same units on the X and the Y axis, but it did work nicely for this problem. So now that we have the axes set up, we can just start plotting the points. So we've done this like in Algebra 1, Algebra 2. So we're going to plot the ordered pair 27, 30. So 22, 4, 6, 7, and then 30 would be right here. 44, 19. Here's 44. 19 would be right between 18 and 20. 32 and 24. So there's 32, 20, 22, 24. And then you can just continue to plot all of these other points. And that, as you should know, is how you make a scatter plot. 12, 14, 16, 17. So hopefully you guys are following along and making your scatter plot. And so the scatter plot kind of demonstrates what's going on with these cars, their weight, and their gas mileage. We also should have a title to this. They didn't tell us where these cars were, so I'm just going to title this 8 random cars, because that's all I know about it, okay? All right. So, again, make sure that when you're making your scatter plot that you label the axes with the, like what each variable represents, that you title it, and that you carefully plot, okay? We are going to describe this association, but before we do that, let's talk about ways to describe an association. What do I mean by association? When I say association, two variables have an association if, this is how the textbook defines it, if specific values of one variable tend to be paired with specific values of another variable. We'll talk about that in a little bit. Like, what does she mean by that? We'll try to explain it down there, okay? One thing in an association is that only trends and tendencies can be observed in an association. So only trends and tendencies can be observed. You cannot say that there is a definite relationship. So just because we observe a characteristic about an association doesn't mean that there's cause and effect or that that definitely is going to occur. We're just looking for kind of like a tendency, okay? So to discuss the association, there are 3 important characteristics that we talk about. One is the direction of the association. The direction of the association is kind of like, to be honest, it's kind of like looking at the slope of a line. In a positive association, the textbook says that large values of one variable are paired with large values of another variable. Another way to think about that is that as x increases, y tends to increase. Now, don't just say that as x increases, y increases. This tends to is very important. Again, that deals with the trends and tendencies that we see in an association. It doesn't mean that as x increases, y has to increase. So you kind of cover your butt a little bit and you say tends to increase. Now, in a negative association, that's when large values of one variable are paired with small values of another. So what that means is that as x increases, that y actually tends to decrease instead. Again, that tends to is important. It doesn't mean that as x increases, y is definitely going to decrease. It's just if you look at the majority of the data, that's what we would expect to happen. So notice a negative association is not decrease, decrease. As x increases, y tends to decrease. That's what gives it that negative slope look. Another possibility is no association, and that's when knowing the values of one variable does not give any useful information about the other. So that means that you can't tell if it's going to go up or down. It's kind of just scattered all over the place. That would be no association. Okay? So that's one thing that we can talk about is the direction of an association. Another thing we can discuss is the form of the association. And there are just, two different forms that we generally talk about. One is a linear form, and obviously that's a pattern best described by a linear model. This is pretty much the one we're going to be focusing on here is the linear form. But I do want to point out that there are also nonlinear models, and that's when the pattern is not best described by a linear model. So it might be something like a quadratic model. Remember, so if we had something like that, or an exponential model where we had something like that instead. So, but again, usually the ones we'll see will be linear models. But that's the form. We can say linear or nonlinear. And then finally, we can talk about the strength of an association. There is a strong association where the data fits very closely to a line. This is actually not a weak association, but a moderate association. You can see that in this case, for example, it definitely has a positive direction, but notice that there's just more scatter. And this is a weak association. Notice it looks like there's very little direction, but notice it does have a slight positive increase. So this would be an example of a weak association. So now that we've talked about these three different pieces, let's flip back to the front and let's describe the association that we see in the scatter plot. Here's a nice kind of little template we can use for that. We can say that there is a, and then we can talk about the strength. I don't know, I think those are pretty close. I'm going to say there is a strong. The direction we see is going down. As x increases, y is decreasing. So that's negative. And notice it does follow a linear pattern. So we'll say linear relationship. But then let's talk about what two variables that it's between. Between the weight of a car and its gas mileage. So that's kind of a nice way when it asks you to describe what you see in the scatter plot. That's a nice way to do it. Talk about the strength, the direction, and the form of the association. Okay? So what I'd like you guys to do now is to flip back to the back. And based on what we've talked about here, take a minute and try the your turn. Okay? So go ahead and pause. Okay. So this was about the quick sell car dealership. We wanted to see what variable would be the explanatory variable. And so we were looking at the number of TV ads and the number of cars sold. Well, we're more interested in the number of cars sold. That means that's the response variable. So by default, the number of TV ads should be the explanatory variable, because that could be used to estimate the number of cards sold. Then in letter B, if there does appear to be a positive relationship between number of cards sold and number of TV ads, does that mean that running more ads on TV will cause more cars to be sold? The key word here is cause. And even though that's what we would expect because of that trend and tendency, we cannot say that there's a cause and effect relationship. So we would say no. And here's a sentence you can use like for almost every homework this chapter. Associations only describe trends and tendencies, not definite or cause and effect relationships. Okay? So now some of you guys might be concerned because maybe some of you guys thought that was moderate instead of strong. Well, that's what we'll discuss in topic 2. We'll discuss how can we come up with a value for this strength of a relationship. But today, you'll just focus on scatter plots. Okay, thanks.